Hello. All right. Welcome to Verkle Implementers Call number 12. This is issue 950 in the PM repo. Let me share the agenda quickly in the chat here. Today we have, I believe, 5 agenda items. Six. Starting off with client team updates, we have some testnet updates. We also have EIP 2935 block hash, some updates there. Guillaume recently opened a new EIP for the state transition method. There is a proposal for code packaging in Verkle. And then, assuming we have time and we can get through all this quickly, some testing team updates at the end. And I think that's it. Cool. Client team updates. Would anyone like to go first?
I think I can give a quick update from Netherlands. There is no big changes. Just we tried to join the testnet and we found out a few issues. And the same time trying to rebase changes on the Dencon updates. And yeah, that's it.
On Ethereum just side, so we were also able to join the testnet and we were able to sync up till some 478 block, and we sort of ran through issues on 479 block. And even before that, we ran through some issues which we discussed and debugged and sort of applied some patch to sync through constant info. But currently, I think we would need the new network launch so that basically we can execute stateless on the witnesses which are missing in the current testnet, and without which will not be able to execute further. With regard to block hash, Johan has sort of completed the block hash implementation and will be able to use it. Currently, basically in the current syncing, we were not resolving block hash properly as well. So that could also be the reason that we might not be able to execute few of the blocks of this particular testnet.
Update from the Nimbus team. So the last 2 weeks, we put in some effort to optimize the deserialization function for bandwagon base field points because it was pretty slow as compared to like the Go implementation. After optimizing, basically what we implemented is we implemented the D-log pre-compute that is meant to be done for calculating square root of points. And turns out that currently overall the Nimbus cryptography library that is there in Constantine is at least 19% faster than that we have at Go. And from the integration perspective, we are almost done with the stateless primitive testing that is like in consistency with the Go implementation. And we have come to a conclusion that we can start off integrating into Costinum via the Nimbus execution client first. So we are currently looking into that. That is pretty much the update from the Nimbus side.
For Besu, Karim from Besu has left some message to read here, so I'll just read it. We've made changes in Besu to connect to new testnet, Genesis configuration, etc. I think there's a bug about next fork block in get. Already talked to Guillaume about that. EIP 2935 has been implemented, allowing the storage of block hash history in the state. Gas cost modification for Verkle are still in progress. There are some bugs, but we managed to import more blocks with contact creations and transfers. We've also been able to fix rollback bugs in Besu. important to manage reorgs. We'll soon need to focus a lot on performance, but that's in the coming weeks. So regarding that, we need to change the tree to compute, to sparsely update the commitment, not to recompute all the 256 values every time something is needed to change in the tree. So that's next for the performance.
Yeah, we have been working mostly to help other clients join the testnet. So indeed, like people already mentioned, there's a few bugs that have been uncovered, so that's good. None of them will be fixed for this instance of the testnet because it doesn't look very critical. I mean, you can work around it, and we can keep looking for bugs. So that's the way that seems the simplest at the moment. Otherwise, we did a lot of specking. We wrote some changes for the EIP 4762, the gas cost EIP. There's been a complete redesign of EIP 2935. And I also created a first EIP to describe the transition. But I will cover that later. And yeah, we also worked on testing tools. So yeah, we hit a few roadblocks, but I just pushed a couple fixes this morning. And otherwise, yeah, Ignacio has worked on reactivating the replay so that we can produce data from the current height of the chain. See if we can well, first confirm that we have something that works in with a more modern payload, like real payload, and also do more performance testing, check the size of proofs, etc., etc. And I think, oh yeah, I did a bit of. There's been a bit of rework for the shadow fork code, but yeah, no bug fix, just some preparatory work, and yeah, that's it.
Just to extend a bit on that update, and I won't get into the details because I think this is the next bullet point. But you have the mic open.
Yeah. It's about 500K probably.
Okay. So yeah, we kind of fixed some bugs that will probably be run in the next testnet. Just, I think most people here already know about that, but I will just quickly mention. There was like a bug for 2535 that Kachinder found regarding an undesired effect of EIP 158, deleting stuff from the block history contract that we created. He also found some other bug regarding the not recording witness data correctly for addresses that were, let's say, smaller than 20 bytes. Also, Danish found some other bugs regarding some opcodes that weren't recording witness accesses, such as balance and external code hash. So I fixed that too. And as Guillaume said, we are now able to replay at this moment 5 million blocks in importing a chain with the Verkle tree logic, and that allow us to find a really nasty bug that caused like an integer underflow, which caused an infinite loop, which caused an out of memory problem, which is one of the reasons why we like replaying these long chains, because this happened like 4 million blocks after the start. So it's a bit of a nerve-wracking kind of bug because an infinite loop is pretty bad, but that simply means that we have to do some extra work in testing. And this is kind of the bugs that are found with some fuzzing. And also the fact that Go doesn't panic whenever you underflow or overflow. There are other languages that are much safer on that regard, but yeah, just saying that.
Cool. Any other updates? If not, next up, the testnet relaunch. Guillaume.
Yeah, so I would like to bring your attention that now Barnabas, every time there's a new testnet relaunch, produces, so I'm sharing my screen, I don't know if you guys see it, produces a spec for the testnet. So we have one active where all the bugs are currently described. So there's the block number. So most of them have already been mentioned by everybody affected, really. But so yeah, you typically when we find a testnet, we will when we find a bug on the testnet, we will try to update the spec sheets to specify if it got fixed after, like if we decide to fix the bug and continue, or if we just decide to wait for the relaunch. So far all the bugs have been estimated to not require a relaunch, but since they're accumulating, at some point we will try to do this. But yeah, one thing I forgot to mention, so we launched DevNet 3 last week, but we found already some bugs, so we fixed them and we relaunched after a couple of days. So number 4 is going strong so far, so this is good. Yeah, so I just wanted to mention that. So if you have any questions or if you find any bug, go there first. Tanishk has found the bug with self-destruct, or at least thinks there's a bug. We are still investigating the last one we know of. And there's also the one that's not mentioned here that Karim described. It seems that Geth is sending the wrong fork, next fork value, namely that it sends Prague instead of sending 0 when Prague should actually already be active. But yeah, these things you can work around them. So currently we don't fix them. I mean, we will fix them before the relaunch. But yeah, it doesn't seem to be a showstopper for now. So yeah, that's pretty much it for that.
Yeah, Barnabas.
I would also like to mention that Kurtosis is now capable of doing shadow forks out of the box. So there's a way where you can test your ELCL implementation, whether it will go through the Holosky fork transition using a state that was taken before Denkun. So this is a state that is pre-Denkun, and the state is about 16 gigabytes. So it will take some time to download that state, but we offer it in a S3 bucket, and it would be great if different client teams would be able to start using this and start testing it.
Yeah, so just to add to this, so I did start using it this morning. Works really well, and Geth immediately dies. So I mean, immediately, like after a dozen blocks. But yeah, to run it, you need to be able to support the transition. So, but yeah, if you want to try to join that, that's extremely useful as well, indeed.
You mean it dies before Electra is hit?
It dies before, I don't know, the transition starts and then it dies. Like
Yeah.
it produces a block that it can't reinsert in itself. So yeah.
And if you find any bugs, just create an issue or let me know, because I can quickly fix it.
Cool. Okay. Next up, some updates on the implementation of EIP 2935. Gajinder?
Thanks, Josh. So basically, we had discussion with Ganesh and Guillaume, and we basically came to a simplification in which what we are doing is we are writing the entire. So whenever there is a fork block, the first block of the fork, we are persisting whatever required history is needed for that block to execute. So basically, last 256 block hashes and in the slot, and basically this solves the problem that it simplifies and solves the problem that okay, we don't need to detect the fork height anymore, and so with just one access to the slot, one can figure out okay whether you have the block hash or not. So basically, if you look at the EIP, there is a pseudocode that's basically at the start of the block, you insert the parent hash of the block into the into the slot, and if this is the first block of the fork, then basically you insert extra 255 ancestors, and the way you resolve it, so you can now switch the resolution of block hash directly on the first fork of the block itself to just doing a lookup in the state for that particular slot. And if you note that now basically you can have a lookup on a bigger range, which is basically the entire max history window, which is basically all the slots that are there. So earlier you could only look for 256 blocks, but with this EIP update, you will be able to look at the entire range, whatever is there till the wraparound happens. So then there is a question regarding wraparound, and that is what is the size of the block number, because slot size is 256 bits and the block number is 64-bit as per my understanding as of now. So arg is going to be of the same size. So the question is whether we take care, we basically consider that there is a wraparound that is going to happen, or maybe in future when that arg, when the block number size could be increased, then basically we add in this condition. So thoughts and comments are invited on this.
Sorry, there's something I didn't quite get. So you said the wraparound is going to happen at 64 bits, right?
No, wraparound will happen at 256 bits only, but our current block number size, I think, is 64 bits. So,
right.
I mean, I'm not sure how that situation will pan out. Whether before this we come to this situation, we might increase the size of block number. I'm not sure how that is going to happen.
Yeah, I think we have for a couple million years before that happens. Because the order, yeah, I would have to write the math down, but if I'm not mistaken, we're gonna be fine for a long time. Yeah, okay. But okay, so if like the wraparound would be 256, I think we're fine, right? Because that's more time than is left in the life of the universe, I think. Yeah, exactly. That's a lot of time.
Yeah, so basically maybe we can then move the wraparound condition itself. That basically checks. So there are two there. So the condition before we actually look into the block is that the arg has to be less than block number, and obviously it should not be wrapping around. So maybe we can remove the wrapping around check.
But actually, no. I was just thinking because like realistically, it will not happen. But you have to check the lower bound because yes, it will wrap around if you start asking for a negative block, right? And that should be maybe what the check is about.
So okay, maybe we can So we can check for the negative block and basically check that arg is, if your arg is less than, so arg cannot be negative because arg the input arg is uint, right? So I'm not sure how we'll get a negative arg anyway.
Okay. Yeah, I guess we just need to continue talking offline. Thanks.
Okay, next up, we have an EIP for the base EIP for the state transition method. Guillaume?
Right. So last time I made a suggestion to have a less ambitious fork, and is that the right window? Yes. So I created an EIP for that, and I'm aware that yes, there's been a lot of pushback, so that's understood, and I also won't seek to push this any further. However, it serves. I still wanted to create the IP for two reasons. The first one is because that's a first. Let's say that can be used as a base to be extended to create the full-fledged EIP, which I'm currently working on, but I need to keep learning a bit more about how EELS is built, because presumably we would use this their terminology to describe the EIP. But so before I do this, I was like, I'm going to take the common denominator, which is basically this EIP, because this EIP is the first step that you can then extend with the full-fledged transition. And the EIP number is 7612. So I just meant to have this EIP, like I said, to as a base for the next EIP that's coming, but also in case during development we change our minds, we say no, actually doing just the overlay tree and taking care of the conversion later makes more sense at this time. Then we have an EIP to fall back to. But like I said, it's not something I'm pushing for at the moment. But yeah, if you could just have a look and give some feedback if you can, that would be really appreciated, because it's going to help with the next step, which is the full EIP, like the full conversion EIP.
Cool. All right. Next up, we have a proposal for code packaging that I believe Pavel, Guillaume, and a few others have been working on. Pavel, did you want to start with any thoughts there?
I don't see him in the...
Is he not here?
No, I don't think he got the message.
Okay, well, yeah, maybe, yeah.
Next week, I guess. I wouldn't be able to present it, but the idea was that there was a couple ideas that were quite interesting. I would prefer him to present it, but the idea was to do some packaging of do the packaging differently. Namely that you would have chunks of 32 bytes, and then you would have a map that says for each block that starts, for each chunk that starts with push data, that map would tell you, okay, this is where it starts. And yeah, it has a few interesting ideas, so I encourage people to go have a look. Clearly, it's EOF based. We could also implement those ideas without EOF, or more exactly, to pave the way for EOF. I had a couple of questions for Pavel myself, so I really don't want to be the one presenting this. But I think it's quite interesting, so we should, I think everybody should have a look and try to come up with questions for Pavel next time.
Cool. Okay. Then we can move on to testing team updates. Mario, are you around?
Yes, I'm here. Can you guys hear me?
Perfect.
Yeah. So we've been doing some implementations and changes to the execution spec tests repo that we have to accommodate for Verkle. So far, we've started with the very basics, which is the transition tool support changes that we need for Verkle, which is the tool that we use from Geth to fill every single one of our tests. And we've been working with Guillaume to make this possible. It's still a work in progress, so we at the moment are not able to generate any tests. But when we do, I have some suggestions, and I wanted to just share them here to make sure that we are on the right track. So this is very subtle, but I wanted to share my screen. I don't think I can. No.
Oh yeah, sorry. Give me 1 second.
Yeah.
Oops, I don't want to do this. No, it's sharing my screen. 1 second, sorry.
If it's not possible, is very little information. I can just okay.
Yeah, if you just
But
give
it's
me, up to you, but if you give me 1 second, you should be able to. I'm trying to find this toggle. Oh, sorry. Okay, here you go. Sorry about that. You should be good now.
Yeah, I can see it now. Perfect. Okay, so can you see my screen now?
Yep.
Yeah. Okay. So yeah, basically we have this definition of forks in the execution spec test. So we started with this, assuming that the current implementation Verkle is on top of Prague, and Prague is not on top of Cancun, but it's on top of Shanghai. This is what we define. So we have two important forks defined, and one is the straightforward Prague, and the other one is, I think, more important, is the Shanghai to Prague Verkle transition. So these are the two forks that we plan on using to implement all of the Verkle tests. And the main difference between them, and I think most of the things we'll have to implement something in their Genesis parsing tool to be able to consume our tests. But the first one is Prague, when we start with the Genesis that will have Prague activated with Verkle. And the purpose of this is just simply from the very Genesis, we provide a pre-allocation for all of our tests. And the idea here is that the clients consume this pre-allocation for the test, and it will go straight to the Verkle tree. I think this first approach is just to make sure that everything works. I mean, all our tests that we implement, they work on, they make the proper modifications to the Verkle tree when we have already converted to fully converted to Verkle tree. And this more interesting one is the Shanghai to Prague Verkle transition, which is basically just we start with Shanghai or whatever previous fork we are forking to Verkle, and then on the first block we fork to the Verkle transition. What this will allow us to test is that we have a Genesis that defines the pre-allocation to all of the state accounts that, for example, we use the smart contracts that we use to test every single one of our tests. We start with that on the Genesis, but the Genesis is pre-Verkle, so we will start with the MPT tree. And then on the first block, we will go to Verkle. And I think this is very interesting because it will allow us to start with the MPT with all our accounts, and then on the first block we start sending the transactions that the tests that we write and that we have written already, all do the execution when we are already converting to Verkle. And not necessarily converting, but also on the overlay tree. That would be very interesting to test. And another good thing about this is that we have implemented this feature on our repo that would allow us to not only produce a pre-allocation with the things that we need, but we also can feed the MPT tree to have a lot of information, a lot of, not random, but maybe we can design some interesting patterns for the conversion or for the overlay tree that we can inject into the MPT. So we can test this in a regression fashion instead of having to, for example, shadow fork into something. We can first start test here with a big MPT with a special pattern, and then we can proceed to the shadow forks and more so. But yeah, the problem is that this still doesn't work. We're working on it, but yeah, this is basically the idea, the main idea of how we are thinking on filling the tests at the moment. And yeah, I would love to hear if you guys have any doubts, or maybe this doesn't sound reasonable or anything. Yeah.
I have a couple questions. So one of them is what is this interface you showed us? Is it like some tool of yours, or is it something standard I don't recognize?
Yeah, sorry. This is the let me share again. This is the documentation of the execution spec test. So we have this. This is basically the site that renders all of the documentation for tests. It contains the definition for all the forks that we use to test, and also the fixture formats that we produce. So right now we produce three fixture formats, so the state test, the blockchain test, and the blockchain hive test. So I think we can fill using, for the Verkle tree tests, we can fill the three fixture formats, and we can run them in different ways. I think for Verkle transition, only blockchain tests and blockchain hive tests are interesting, because state tests wouldn't be able to do the conversion at any point. But yeah, these are the two interesting ones for Verkle.
And would it be possible, like when we start adding more clients? I mean, I assume clients could already join the first batches of tests, right? The one without the conversion. Would it be possible to somehow make, run all those clients that are available nightly and produce a result, like show a page where each client is, so that we can keep track?
Yeah, so I think we can do this with the way that we do this for Cancun. We have the high view renderer. So we run all the Cancun tests on loop every night, and this page just keeps updating. We can do a similar page once we are able to generate the blockchain hive test. This ones, I think we can run on loop for Verkle with all the clients, the same way that we do now for Cancun.
Cool. And I had another question that's related to the question I asked you on Telegram. So in order to perform the conversion, I would need I need a snapshot. So the question is, well, you said, you wouldn't really be able to pass the snapshot. That's fine. I could regenerate it. The question is, how much time do we have to run those? Like, is there a timeout for these tests to run?
No, not at all. That was what I was thinking. So I think we can selectively generate these tests, because I think it would be very intensive to start adding a lot of stuff that is necessary for Verkle. But there's no timeout, but it might take a lot because this is Python, so it's not very efficient. But anyway, I think if we need to add it, it's possible. We might just generate them more sporadically as compared with every PR, for example. Right now, we generate every single test with every PR. So right now, I think we can lower that that period and just make it so that Verkle tests are generated every I don't know, maybe release or something. But it's not a problem regarding to timeout. That was basically it. Yeah, if you guys have any input or ideas on what we can do with testing, we have now a Verkle branch, which is out of date right now. I'm gonna update the this branch with. Let me just share the link. I will update this branch with the transition tool updates that we're making. But this will be the branch that we will start adding Verkle tests and everything Verkle related. So just so you guys know. And yeah, that's basically it.
Awesome. Thank you, Mario. Okay, cool. I think we do have a last minute addition to the agenda from Kev. Kev?
Yeah, thanks for that. Sorry, my audio is a bit bad. Essentially, I think me and Ignacio spoke about it a month or two ago. It's replacing the .serialize method in Pedersen hash for basically a map to scalar field. I wanted to check if anyone's against that, and yeah, basically check if anyone's against it before making it, since it's a breaking change.
So wait, I didn't get it. So you want to remove all serializations and just use map to scalar field?
I wanted to remove the .serialize method for map to scalar field. So you'd still return a 32 byte value. It's just that you wouldn't be using it.
I think we lost you, Kev. You may not.
Sorry. Oh, that
Yep.
was it.
Okay, got it. I dropped a link in the chat. I don't know if anyone else has any questions or thoughts on that. If not, all good. Cool. Well, we made it through all the agenda items ahead of time. Anyone have any last minute additions, thoughts, or we can just end there? Cool. Well, thank you, everybody. And we will see you again in 2 weeks.
Thanks.
Bye-bye.
Bye.
Bye. See ya.
Goodbye.